by measurement. All right. Now, it is expressed as a numerical value multiplied by a unit. So you have the quantity. The quantity may be like 5.2 as we have here. Then the unit could be meter or 5.2 kilometer, as the case may be, and so on and so forth. All right. Or in the case of, let's say, speed, where you have it as meter per second, like 20 meter per second. The numerical value, which is the magnitude, my dear student, is the 20. Then the unit is meter per second, which is the unit for speed. So that is what we are going to start with. A physical quantity is a property of a material or system that can be quantified by measurement. That can be quantified by measurement. That means you can tell the amount that is there by measuring it. All right? And it is expressed as a numerical value multiplied by a unit. Example is length, for instance, 5.2 meter, and then speed, 20 meters per second. All right? Now, the physical quantities in physics are divided into two, my dear students. How many? Two. We have what we call the fundamental quantity, and we have what we call the derived quantity. Now, my dear students, if I should ask each and every one of us, what is fundamental? Right? Now, when I was teaching you guys chemistry, I taught you guys the origin of the atom. We are philosophers, we are looking for the fundamental stuff of the universe. That is the basic building block of the universe. Right? I would say the basic building block of the universe is what? According to chemists as at that time, of which the chemist in question was Democritus, who said was atom. Right? Exactly. Then when we now come to biology, we said the basic building block of life, of biology, is what? A cell. So when we talk about the fundamental quantities in physics, we are talking about those quantities that are like the basic building block of physics. That means those quantities that are there. They don't need any other quantity for them to be formed. They are like the oga patapata of them all. They are like the basic. Are you getting it? No other quantity makes them up. They are just formed by themselves. Those are the fundamental quantity. Now, as name implies, derived quantity. I believe all of you read stories in the Bible where Moses was drawn out of water, derived from water. That was the name Moses, derived from water. That means it was gotten from water. Now, same thing applicable here. When we talk about derived quantity, my dear students, we are talking about quantities that are gotten from the fundamental quantity. So all quantities that are gotten from the fundamental quantities are the derived quantity. All right? So we have two types of physical quantities. What are they? We have the fundamental quantities, and then we have the derived quantities. Those are the two basic types of physical quantity. Of course, we say fundamental are the basic building block, all right? And then we have the derived quantity. Now, let us look at what the fundamental quantity is here. It's a very simple concept anyway, all right? It's a very simple concept. Okay, this one is just the size increase, all right? Then brush, highlighter, okay? Trying to still learn how to use it. Now, these are irreducible. These quantities are what, my dear student, irreducible, meaning you cannot reduce them, all right? They are independent. They don't depend on any other quantity, building blocks of physics. They are defined by the International Convention, that is SI unit. SI unit, of course, you've heard of the System International Unit. That's what we call the SI unit. And are not defined in terms of other physical quantity. What we are trying to say is that other physical quantities do not join together to form this fundamental quantity. What will they try to talk? They say the fundamental quantity and then be the basic. If you want to build a house, what is the starter? Now block. That one block now be fundamental. Are you getting it? For you to get a full fence, you need to add more block, more block, more block together. For you to get a full room, you need to add blocks together. But that one single block is the fundamental quantities. And these quantities we are saying in physics are quantities that do not depend on any other quantity for their formation. That is, every other quantity depends on them. So if you want to find derived quantity, my dear student, derived, you must get them from the fundamental quantity. But if you want to get the fundamental quantity, you can't get them from the derived quantity. That is what it implies. All right? That is what it implies. All right. So that is that. Now, the fundamental quantity, there is something that could be a bit confusing here. The fundamental quantity, there's what we call the basic fundamental quantity. Now, when we say something is basic fundamental, that is a tautology in English language, because fundamental and basic, they are the same. But what we are just trying to do is that we want to distinguish between these three fundamental quantities and every other one, because these three fundamental quantities are like inside your avian, another avian the inside. Are you getting it? So even as all of them they more important, even as all of them are the basic building block, there are some that most other quantity depend on more as compared to the other. Is that okay? There are some that the derived quantity depend on more. Most likely, there is no derived quantity you will see that may likely not contain any of these three, which is length, mass, and time. All right? So we call them the basic fundamental quantity. My dear student, what do we call them? The basic fundamental quantity. And we have length. The SI unit for length is meter. The SI unit for mass is kilogram. Meter is given as what? M. Kilogram is given by kg. All right? The SI unit for time is seconds, which is x. All right? Then we have others like electric current, which is measured in ampere. Then we have temperature, measured in Kelvin. Amount of substance, measured in mole. And the symbol is mole without E. And then we have luminous intensity, which is of course measured in candela. Is that okay? CD, candela. All right. Now, so mass, length, and time are what, my dear student? The basic fundamental quantity. All right. Why electric current, temperature, amount of substance, luminous intensity are what, my dear student? They are. It's also fundamental quantity, but not as fundamental as these first three. All right. And you should be able to know the units of their measurement. Very, very important. So total, we have how many fundamental quantities? 7. Are you getting it? 7 fundamental quantities. Out of the 7 fundamental quantities we have, 3 are very, very important. And those 3 are mass, length, and what? Time. Is that understood? So that is that. Now, derived quantity. What are derived quantity? Now, like I told you before, what did I say derived quantities are? What did I say derived quantities are? Now, talk to me. Talk to me. What did I say derived quantities are? We say they are quantities that do not depend on any other quantity for their formation. All right. All quantities that do not depend on any other quantity for their formation are what, my dear student? Derived quantity. This one is stopwatch. So you should tell me. Oh, good. Okay. Those are their derived quantity, my dear student. All right. Sorry, those are fundamental quantity. That's when I don't go make me lose focus. Now, the derived quantities are physical quantities that are defined and expressed in terms of the 7 fundamental quantities. That means they depend on the 7 fundamental quantities. Now, my dear student, what are the derived quantity we looked at? The derived quantity we looked at are mass, length, time, current, which is measured in ampere, luminous intensity measured in candela, temperature measured in Kelvin, and amount of substance measured in mole. These are the 7 fundamental quantity. So any quantity that maybe you add, subtract, multiply, divide any fundamental quantity, and you get that particular quantity, then it is a derived quantity. Are you getting it? For instance, if I put length times length and you give me length square, this length square will form now is a derived quantity. Do you understand? If I press maybe mass times length times time, what I got now is now what? MLT. This MLT I've gotten is a derived quantity. So when you multiply, or let us say I put mass meter per second. This per means division now. Is what I got here now is what, my dear student, a derived quantity. Is that okay? So that is what a derived quantities are. They are derived quantities. They are quantities that are obtained by multiplying or dividing the fundamental quantities. All right? Those are derived quantities. Now, let us look at some of the derived quantities and their units. All right? Now, we have area. The first derived quantity we are going to look at here is what? Area. My dear student, what is area? Area is length times breadth. Or some persons will say length times length, depending on the shape that was given to you. Now, there is something I want you people to understand. There is something I want you to understand. What is that? Now, length in fundamental derived quantities and the rest is equals to breadth, is equals to height, is equals to depth. Are you getting it? All of them are distance. The same thing as what? Displacement. So whenever you see length in these quantities we are looking at, it also means breadth. So if you see breadth, you can represent it with length. Are you getting it? If you see height, you can represent it with length, because the only fundamental quantity we have that has to do with distance from one place to another is what? Is the length we have here. Is what, my dear student? The length we have here. All right? So what I'm trying to tell you now is that if you see breadth, represent it with length. If you see height, represent it with length. If you see depth, represent it with length. If you see distance, represent it with length. If you see displacement, represent it with length. So area is length times breadth, which is length times length. All right? Length times length will give us what? L square. Now, L square, the unit for length is what, my dear student? Meter. So the unit for this one will be meter square. It's a very simple thing. So the unit of area is meter square. Now, this is very basic. We will be going a little bit advanced. Now, volume is what, my dear student? Volume is length times breadth times what? Height. What did I say? Wherever you see breadth, represent it with length. Wherever you see height, represent it with length, because the only fundamental quantity we have there is that has to do with distance is length. All right? So this will give us length times breadth will still be length times length, which of course length times length times length will give us length to the power of 3, which will give us m to the power of 3. All right? So that is that for this particular one. All right? The next one is speed. Speed, my dear student, the formula for speed. So you must know the formula. Formula for speed is distance over time. So speed is distance over time. Now, what did I say distance is? Distance is what? L over our time, T. So what is the unit now to be? Meter divided by time is what? Seconds. Now, my dear students, if this meter per second, this is, whenever you see anything standing on its own, it's raised to the power of 1. And anything that is crossing this sign here, this quotient, this line when they see, if you see anything meter per something, once this thing they cross to the other side, because you want it to cross up, the sign will change from positive to negative. If not positive there, Why if na negative dey here, it will change to what? Positive. So we have meter. I want this s to come up so that it should be in the linear form. Now, because of course, if anything is standing on its own like this, it tells you that what is here is what? Positive. So this one will be meter per second, like this. Why? Because this thing, as it crosses up, it becomes what? Negative. Because what we have here is positive. But you know, most times we don't usually write positive. So these are the various units of these quantities. All right? These are the various units of this quantity. Of course, we said area, meter square, volume, meter cube, speed, meter per second squared. All right? Now, let's look at another one. Another one is acceleration. My dear student, what is acceleration? Now, acceleration is what? First of all, we need to look at velocity before we look at acceleration. Let's look at velocity here briefly. Velocity is displacement over time. My dear student, what is displacement? And what is the difference between displacement and distance? That will be an assignment for you. All right? Assignment. So you do that assignment, you submit to me to look at. All right? What is displacement? And what is the differences between displacement and distance? Now, in the context of physical quantities, I told you both displacement to both distance, so all of them, they are represented with what? L. Is that okay? They're represented with L. So our velocity, my dear student, will be what? L over T, which is L is meter, T is what? Time, which is seconds. Of course, I told you that this raised to the power of 1. If it crosses up, velocity will be meter per second, which is the same thing as what we have done before. All right? So acceleration will be velocity over time, my dear student. That is the reason why I had to do velocity first. Is that understood? Acceleration is velocity over time. So what do you think will be the unit for acceleration? Now, velocity is what? Meter per second. So you just put it in meter per second all over. Time is in seconds, raised to the power of 1, of course. All right? You cannot cancel these two. These seconds raised to the power of 1 have to cross up. So acceleration will be meter per second times. If this second to the power of 1 crosses up, it becomes seconds minus 1. I told you why it's like that, because whenever this one is crossing up, the sign changes to negative. All right? So acceleration would be m. The bases are equal. I taught you indices, right? I taught indices in school. When you have two things, or when the bases are equal, what do you do to the power? You add the power. And multiplication is in between them. You must ensure that multiplication is in between them first. All right? Okay, this one is. You must ensure that multiplication is in between them first. All right? What color is this? I think I prefer. Now, you must ensure that multiplication is in between them first. If multiplication is in between them and the bases are equal, collect one of the bases and then add the power. All right? So, at the end of the day, what are we going to have? This will give us, collect one of the bases, which is x, then add the power. Minus 1 plus bracket minus 1. All right? So, acceleration will be equals to mx. So we have minus 1. Plus times minus is what? Minus 1. So acceleration will be mx. Minus 1 is what? Minus 2. So this is the unit for acceleration. All right? This is the unit for acceleration. Is that okay? Now, the next one we will look at, my dear student, is force. The next one we are going to look at now is what? Is force. All right. So the next thing we are going to look at now is force. Now, my dear student, what is force? Force is equals to mass times acceleration. All right. So if force is equals to mass times acceleration, what did we say the SI unit for mass is? Can you still remember? The SI unit for mass is kilogram. What do you say the SI unit for acceleration is? Meter per second square. So you multiply it times meter per second square. So force will be kg meter per second square. All right. So that's the first thing you need to look at. So you see how we are building upon each of them one after the other. All right. Now the next one is pressure. Now, my dear student, what is pressure? Pressure is force over area. What is our SI unit for force here? Kg meter per second square. So pressure will be kg, which is force, meter per second square divided by meter square. All right, of which this will give us kg meter per second square divided by meter square is still the same as meter per meter. We can make it easy like this. Now this cancels this. We are left with what? Kg all over what? Meter. Now the general idea is that when you want to arrange this thing, there's a particular order I like arranging them. I like going from kg, then meter, then seconds. All right, this is the correct order. So if we want to follow this order to arrange this now, what do you think this whole thing will be? This will give us kg, then meter is supposed to follow, right? But this meter is raised to the power of 1 here. If it crosses up, it becomes what? Everybody knows why. Why is that so? Think. Have some time to think about it. Why do you think this one crosses up and become minus? So I told you that whenever anything is crossing this sign here, the sign it has initially will change. And for it to stand on its own here means it has a positive sign. So crossing up becomes negative. And then of course we have x minus 2. So this is the unit of pressure. All right. The next one is momentum. Momentum. Momentum is mass. Formula for momentum is mass times velocity. The SI unit for mass is kg. SI unit for velocity is meter per second. So momentum is kg meter per second. Please take note of it. Very, very important. All right, very, very important. Now, the next one is density. So what I'm going to do briefly is just to draw a line here across so that one side will be for density, the other side will be for torque. So that will not make things okay. Now my dear student, what is density? Density is mass times volume. That is the formula for density. Mass times volume, not velocity. Volume. Or mass over volume, rather, not times volume. All right. Mass is what? M. Volume is what? We said L to the power of 3. All right. That's volume. Length times length times length. That's L raised to the power of 3. Now, what is the SI unit of mass? Of course, we said it's kg. What's the SI unit of L? Length is m to the power of 3. All right? So that at the end of the day, what we are going to get will be kg. What did I say if this one crosses up? Oh yeah, think. What did you say it will now become? It will become m to the power of minus 3. Abina, exactly. So this is the SI unit of density. All right. Now the next one is torque. Torque is force times the perpendicular distance. Torque force times the perpendicular distance. Is that okay? Now, my dear student, what is torque? Force times perpendicular distance. So our torque will be force is what? The SI unit for force is kg meter per second square times r is the radius, which is distance. I told you that whenever you talk about distance, you're talking about what? Meter. All right? So our torque will be kg. This meter here, we multiply this meter. When both of them multiply, it will give you meter square. Then we have per second square. So this is the SI unit for torque, kg meter square per second square. Now, on the other hand, there's another way of solving this torque entirely. Torque, of course, is force times perpendicular distance. Now, another unit for force that we've not discussed since is Newton. So Newton arrow is meter. All right. So most times, some persons will just say torque, or some textbooks is Newton meter. All right. So that is the answer to that particular one. Torque is Newton meter. Let's see the next one. The next one is stress. What do you think stress is? Stress and strain. I have to rule a line. What is stress and strain? Now, my dear students, stress is force over area. More like pressure, right? Which, as we said, force is Newton. Area is meter square. That's another way of writing it. So most times, a person will just say stress is Newton. Meter square crosses up, becomes minus 2. You know why it's minus 2, right? I told you that whenever the sign is changing, it becomes negative. Or you could also say that stress, force over area, force is what? Kg meter per second square. Area is what? Meter square. All right. Of course, I told you that this one, kg meter per second square, all over. Meter square will be meter times meter. All right. Now, when meter times meter, one of these meter can cancel this one. And I told you the right order. The right order is what? The right order, I said, it usually goes from kg, meter, and second. So in this case, kg here will become kg. This meter here, raised to the power of 1, if it crosses up, are you getting it? And then this one will be minus 2. So that is the answer to that. Because this one and this one cancels. This meter here, raised to the power of 1, if it crosses up, becomes what? Minus 1. Are you getting it? Then, of course, this x minus 2. So it has the same units as your pressure. Look at it. It has the same unit as your pressure, kg per meter per second square. Is that okay? The same unit. So pressure and stress has the same unit. Is that understood? Kg per meter per second square. Now let us look at the next one, which is strain. You need to know the formula. Strain has the formula extension over length. All right? Extension over length. Now strain, extension is still the same as length. If you are extending something, you are just increasing the length, or you prolonging the time. You've heard somebody say things like, why are you extending this issue? The person is just prolonging the issue. Is that okay? So extending means prolonging, like increasing the length. All right, so this gives us is still length, just that the length is increased. So extension, displacement, distance, all of them fall into the same category of length. And of course, we have our length because the formula for strain is extension over length. All right, so my dear students, at the end of the day, what do you think will happen? Length will cancel length, and then, of course, your strain will be length cancels length. What are we going to have? 1. And 1 is dimensionless. Is that okay? It's dimensionless. So when you have two things cancel out and they cancel out, the unit is always dimensionless. Is that understood? So that is dimensionless. Let's look at another one, Young modulus. That's the only thing we have on this slide. Now, my dear student, what is Young modulus? Hey, wait. What is Young modulus? Young modulus is the ratio of stress to strain. All right? Ratio of stress to strain. Now, my dear student, what is stress? Stress is, this is the unit, kg meter per second, kg per meter per second. So we come here and put it as kg per meter per second. Abina divided by strain is 1. All right? So that at the end of the day, you have this, because we said when we did strain, it gave us what? 1, dimensionless. So here will be kg per meter per second. And that's the answer to that question. So now what can you deduce from here? It means pressure, stress, strain, no, not strain, pressure, stress, we have Young modulus, all have the same dimension. Is that okay? All of those have the same dimension. You should take note, because they may ask you a question like this in the exam, where they will ask you pressure, stress, Young modulus. Which of the following have the same dimension as Young modulus? You should be able to state. Which of the following has the same dimension as stress? You should be able to state. All right? Now, the next one we have here is power. Let's look for the dimension for power. Now, my dear student, there are 2 formulas for power, and we are going to look at these 2 formulas for power, all right, and their dimensions. So what I'm going to do, I'm going to divide this into 2. So we have this divided into 2. one side will be for one of the formulas for power, while the other one will be for the other. Now, power can be force times velocity. This is a formula for power. Now, force times velocity. What is the unit for force? Force, we said, remember that force is mass times acceleration. So we'll have mass times acceleration times velocity. Alright? Which is power will be, the unit for mass is what? Kilogram. Unit for acceleration is meter per second square times velocity. Unit for velocity is meter per second. So what do you think power will be now? Of course, this will give us kg. Meter times meter will give us meter square. Then minus 2. Then times what? This other one, which is x minus 1. So power will be kg meter square. The bases are equal. What do? You collect one and add the power since multiplication is in between them. Bases are equal. What do? Collect one and add the power since multiplication is in between them. So this will give us x minus 2 minus 1. Alright? Which will be equals to kg, then m square. Minus 2 minus 1 is what? Minus 3. So this is the unit for power. Now, another thing you should also look at is that power can also be expressed as energy over time. Please take note. Which is also equals to work done over time. Is that okay? Work done over time. So power, energy can be potential energy, kinetic energy. So potential energy, let's work with that one first. What is potential energy? Is mgh all over time. Potential energy. Because we are saying now that power is also energy over time. Now we are looking at one form of energy, which is potential energy. Now, m unit is kg because m has to do with mass. G is what? Acceleration due to gravity. Unit is what? Meter per second square. H is height, which is in meter. I've told you that height, depth, length, radius, displacement, all of them, they are what? Length. So their unit is always meter. Time is in seconds. So power would be equals to kg. Alright? Meter times meter, because we have to bring them together. So meter multiplied by meter will give us what? Meter square. This second is raised to the power of 1. If it crosses up, it becomes what? X minus 2 times. If this one crosses up, which I teach you now, it carries 1. If it crosses up, it becomes what? X minus 2. S minus 1 rather. So P will be equals to kg meter per second square x. The bases are equal. What do you do to the power? If multiplication is in between them, you collect 1 and then add to the power, which is minus 2 minus 1, because plus times minus will give us minus 1. So that finally the answer will be kg meter square seconds cube. Alright, that is the answer to that question. Is that okay? Which is also work done over time. If you also do it in form of work done over time, let me take this small space here and work it out. A form of work done over time. Power, work done over time. What is work done? Force times distance. So force times distance over time. That is work done. Force times distance. So that our power would be equals to force is what? Kg meter per second square times distance, which is this distance here, which is in meter, all over what? Seconds, which is raised to the power of 1. We've gotten to this step again. Are you getting it? So if we follow every other thing down, you will see that we also get kg meter square per seconds raised to the power of 3. So this is the unit of power and how you can derive it. So take note that power can be force times velocity, as you can see here, all right, you should take note, these are the various formula for power. Power could also be energy over time, maybe potential energy or kinetic energy. And power can also be work done over time. Any of the above is actually very, very correct. Is that okay? Exactly. Now, let's look at the next one. The next one is coefficient of friction. Coefficient of friction. Friction coefficient. Now, what's the formula for coefficient of friction? Is frictional force over normal reaction. What is frictional force? What is normal reaction? Now, frictional force is a force that opposes movement, that opposes motion. And that frictional force is also what is making you capable of walking. That's the reason why that you find out that it's very, very difficult for anybody to walk on a smooth surface. For instance, have you ever tried, let me be pouring something very slippery on the floor, like water on the tiles or soap and water on the tiles, and you try walking on that tile? Do you think it's very, very easy to walk? No! So frictional force opposes motion, and that opposition is what also offers us the stability and the balance that we need to walk. Are you hearing me now? So if you are pushing something through a smooth surface, and you are pushing it through, don't know, this is a rough surface, and you are pushing it through a smooth surface, you discover that the rough surface is very difficult for you to push through, while the smooth surface is a little bit less difficult for you to push through. All right? So at the end of the day, coefficient of friction is frictional force all over normal reaction. All right? Both of them are force. What is normal reaction? Normal reaction is, let us assume that this is a share. And I like using this to give an example. And this is your bomb. Yeah, bomb. Hey, Jesus. Which kind of person you should be this? This is your bomb. Now, this is your bomb. You can see here, it exerts a force downward. The force your bomb exerts a force downward. That force that your bomb exerts downward is what we call the weight. So what we call the weight. And weight is given by mass times gravity. Now, as your bomb is exerting a force downward, that shear is also exerting a force on your bomb. That's the reason why you are able to sit down. That force that shear is exerting on your bomb is what we call our normal reaction. All right, normal reaction. Normal reaction. Is that okay? So you should be able to know the difference between normal force, the weight. So me that is sitting on this chair now, as I'm sitting on the chair is also exerting a force on me. Is that okay? That is the reason why on the ground also, as you're matching the ground is also exerting a force on you. That is the reason why when you match the ground somehow, the pain, you will feel it. Why? Because it's exerting a force on you. So frictional force over normal reaction. Normal reaction is a force, and frictional force is also a force. Take note. Normal reaction is what? A force. Frictional force is also what? A force, my dear student. So that at the end of the day, frictional force now would be equals to force. The unit for force is kg meter per second square. Normal reaction is also a force, so the unit is kg meter per second square. All right? So that when you finish, this can cancel this, and this will give us 1. So it does not have any unitless. So coefficient of friction, unitless. You see something like this in the exam, no units. It does not have any units. All right? Does not have any unit. The next one is energy and work. Told you that work done, let me break this down into different categories. In Christ alone, because work done can be in the form of an energy. All right? What did I say is the formula for work done prior to this time? I told you that work done, force times distance, which is also equals to energy. Dimension for force is what? Kg. meter per second square. Dimension for distance is what? M. So work done will be M multiplied by this. That will give us what? kg. M times M will give us what? M square. Then x minus 2. Alright? Then coming to energy. Energy can be in two forms. You can have potential energy, which is equals to what? mgh. Now, what do you think will be this thing? Potential energy is mgh. So potential energy, m is mass. The unit is kg. G is acceleration due to gravity, which is also which is also what my dear student, acceleration. So this will become meter per second square. Our h is height, which is meter. Alright? So potential energy will be kg. Meter times meter give us meter square per second square. Alright? Which is the same thing as what we have here. Then the last one is kinetic energy. It's another form of energy. We expect all of them to have the same unit because they are all energy, just different forms of the same energy. So we have kinetic energy, which is also what, my dear student? Formula for kinetic energy is what? Half mv squared. Nothing concerns us with this half when we are talking about the units. What we are more concerned about is the mv squared. So kinetic energy will be m, dimension, the unit for m is kg, v is what? Meter per second. Of course, this is what? Squared. So kinetic energy will be kg. This multiplied by this will give us meter square per second square. Alright? And that is the answer to that question. It's a very simple one. Alright? So, these are the various forms of energy and work. So you see that energy, work, they have the same unit. Whether this energy, this is what? This work done, this is potential energy, this is kinetic energy. Any form of energy at all, they have the same unit. Now, there's another way of us looking at this also. We said work done is force times distance. Are you getting it? Now, 1 kilogram meter per second square. 1 kilogram meter per second square is equals to 1 Newton. Have you heard of Newton before? Newton, the unit of force. So 1 kilogram meter per second square is equals to 1 Newton. So wherever you see force, you can also use Newton as a unit. So this gives us Newton. Distance is meter, which when you combine them together, they give you what? Newton meter. This is another way of representing our work done. Newton meter. Alright? Newton meter. Another way of representing work done. Now, the next one is the coefficient of viscosity. What did I told you? Coefficient of viscosity is. I taught you this in class before. Coefficient of viscosity is force over area times velocity gradient. Force, of course, is kg meter per second square. Area, meter square. What is velocity gradient? Now, my dear, the velocity gradient is velocity over length. Velocity gradient is what? Velocity over length. So we can say that velocity gradient, what is the unit of velocity? Meter per second over length. What is unit for length? Meter. So when these two things cancel, velocity gradient is per second. Is that okay? Velocity gradient is per second. So Vg per second. Alright? So that at the end of the day, our coefficient of viscosity, now put all of this into this equation. Force is what? Kilogram meter per second square. Area, meter square. Then velocity gradient Are you getting it? Which is this per second. So that at the end of the day, this will give us kilogram meter per second square. This meter square, see it's written as what? Meter times meter. Alright? When meter cancels meter, because this meter can cancel meter, our coefficient of viscosity will be equal to what? Kg. I told you that the arrangement must always go from kg to meter to second. So we have kg, meter. This meter is raised to the power of 1 on that, so it crosses up because per meter. Then this seconds here, you write it per second. So this is the, we forgot that there was per second here. If this minus 1 rather, if this minus 1 crosses up, it becomes, there's no space here, coming. So this will be equals to kg per meter, this minus 2 times, this one crosses up, becomes plus 1. Alright, so this will give us kg per meter. Bases are equal. What do you do to the power? You add them, which is minus 2 plus 1. Alright, this will give us kg minus 2 plus 1 is what? Minus 1. And that is solution to that question. Alright, exactly. Solution to that question, coefficient of viscosity. The next one we will look at now, same coefficient of viscosity, moment. Now, my dear student, what is moment? Moment is also force times distance, all right, which will invariably end up to be Newton meter unit. Or if we want to do it the normal way, force is what? Kilogram meter per second square. Distance is a meter. So when you multiply both of them together, what are you going to have? This will give us kilogram meter per second squared times meter. When this multiply each other, this will give us kilogram meter times meter will give us what? Meter square per second square. All right. Not D, moment. So this is the dimension for moment. I mean the unit for moment, which is also the same thing as what? Work done. Which is also the same thing as what? Energy. So take note in the exam. You may ask which of the following have the same dimension as work done, energy, and co. You'll be able to know that moment have the same unit or the same dimension at the end of the day. We've not come to dimension, but if the units are the same, it means the dimensions will also be the same. All right? The units are the same, the dimensions will also be the same. All right? So that is that for that particular one. Let's see. Now let's look at dimensional analysis. Dimensional analysis is a mathematical technique used in physics, engineering, and science to do what? To analyze the relationship between different physical quantities. All right? To what? Analyze the relationship between different physical quantities. Now, basically, what I would say is that dimensional analysis is used to analyze the relationship between the three basic fundamental quantities, mass, length, and time, and other physical quantities. Is that okay? It's basically used to analyze the relationship. How do these three things combine to give us other physical quantity? That is what they mean. When we talk about analyze the relationship, how do they combine? Is it by division, addition, subtraction? Specifically by division and multiplication. Is it by squared, the square root, and so on and so forth? So dimensional analysis is used to analyze the relationship between different physical quantities, between mass, length, and time, and other physical quantities. All right? Now, what are some of the usefulness of dimensional analysis? One is to verify the consistency of physical equation. Let us assume that you are in an exam and you know that the equation of motion, you have one that is V is equals to U plus AT, but you are not too sure. You are not sure. How do you know? How do you now verify that this equation is correct? It's by using dimensional analysis. Or probably V squared is equals to U squared plus 2A. You are not sure if X is at the end or not. How do you get to know whether there's X there? You use dimensional analysis. Yes, S here. Now, X is equals to UT plus half AT squared. You don't know if T is squared or not. How do you verify? You use dimensional analysis. That's why we said it is used to verify the consistency of physical equation. Number two is to derive potential relationship between variables. Variables are things that change. Velocity change, acceleration change, and time changes. So if they give you velocity, acceleration, time, and force, how do you determine the potential relationship based on the information that is given to you? You use dimensional analysis. You use what? Dimensional analysis, my dear student. What did I say? I said the first one is to verify the consistency of physical equation. Then two is to derive the potential relationship between variables. And then the last one is to convert between different measurement systems. All right? Units between different measurement systems. For instance, you know that we could have force as Newton meter, and we could also have force as kg meter per second squared. How do you convert between these? You use the idea of what? Dimensional analysis. So, one is to verify the consistency of physical equation. Two, to derive the potential relationship between variables. Three, to convert units between different measurement systems. All right? Now, these are the three basic fundamental quantity. I've told you that word three basic is a tautology. It does not make sense. English wise, it's not correct. But we want to be able to distinguish between these three fundamental quantity and other based on their importance or priority. So we have the three basic ones are length, mass, and time. Now, their dimension is often the first letter of the quantity. So length, dimension is capital letter L, must be capitalized. Mass, the dimension is capital letter M. And then time, the dimension is capital letter T. Is that understood? These are the physical quantity and their dimension. And then, of course, their units, meter, kg, and second. This is something we'll be looking at. Then we have the four other basic fundamental quantity where we have current, luminous intensity in candela, temperature is Kelvin, and what? Amount of substance in mole. All these are fundamental quantities, all right? They are quantities that do not depend on any other quantity for their formation. Now, all those quantities, when we say they don't depend on any other quantity, they could be formed on their own, all right? So the next one, of course, we have electric current, ampere. Its measured dimension is I. Now, when you now look at the other four fundamental quantity, they don't follow the normal trend of first letter. All right? Now, if not, electric current would have been E, but now we are saying is I, capital letter I. Then temperature is theta. This is the Greek alphabet theta, which you can see here. Then amount of substance is using N, capital letter N. The luminous intensity uses what? J. All of these are the various seven fundamental quantities and their dimension. All right. take note of it. It's very, very important. Now, dimensional analysis. We have area. Area is length times breadth. I have told you length, breadth, width, height, distance, all of that are measured in what? Length. So if you see breadth, the distance between where you are, anything that has to do with measuring distance is what? Length. So if I have length times breadth, it also means length times length. Alright, the dimension for length is capital letter L. Dimension for breadth is also capital letter L. So this gives us L times L squared. That is dimension for this. Then volume, of course, is length times breadth times height. I've told you that all of these have their dimension as what? As what, my dear student? Length. Dimension for length is length. Dimension for breadth is also length. Dimension for height is also L. So when these three things multiply each other, it gives us L raised to the power of 3. How about speed? Speed, distance over time. What's the dimension for distance? Is also L. Because I've told you that anything that have to do with measurement from one place to another is length. Time is capital letter T raised to the power of 1. So when this crosses, it becomes LT minus 1. Alright? These are very simple things. The next one is acceleration. Now, my dear student, what is acceleration? Acceleration is velocity over time. Or change velocity over time, rather. Velocity over time. So this one gives us LT minus 1. Speed and velocity have the same dimension. The only difference is that speed has to do with displacement. Let me do it here. Speed and velocity have the same dimension. Velocity is displacement. Instead of distance, it's displacement over time. I've explained what distance and displacement is earlier. So we won't go into that. Alright? Now, at the end of the day, so velocity, displacement is what, my dear student? Is also length, because I told you displacement has to do with distance between two places in a specified direction. So we have L over T raised to the power of 1. If this one crosses up, it becomes LT minus 1. So speed and displacement, the same thing. So velocity is still the same as LT minus 1 divided by what? T, because this raised to the power of 1. And then just what do we do? Take this one up, becomes LT minus 1 times T minus 1. When the bases are equal, what do you do to the power? You add them. So this gives us LT minus 1 plus minus 1. Plus times minus will give us minus 1, which will give us LT minus 2. Alright, that is the dimension for acceleration. Is that okay? LT minus 2. From here, you'll be able to predict the unit. What is the unit? Length, measured in meter. Time is measured in second, which is meter per second squared. Is that okay? Then force. Formula for force is mass times acceleration. The first time of when I come to school. Now mass is capital letter M. Acceleration is LT minus 2, which we just did here. So at the end of the day, force will be MLT minus 2. What do you think the unit will be? Unit will be mass is in kg, L is in meter, T is in seconds, which is why we have that. All right? Take note of that. It's very, very important. Now, the next one. Pressure. Why did I say pressure? Pressure is force over area. Now, what does this mean mathematically or in context? It means pressure is inversely proportional to area. So if area is small, pressure will be high. And if area is high, pressure will be low. That is the reason why if somebody has cork shoe, a Keremo get cork shoe, and then you decide to use this cork shoe to hit you, and then somebody has flat shoes, which one do you think will be more painful? Assuming they exert the same force and they have the same weight, which one do you think will be much more painful? Of course, the one with cork shoe. Why? Because that one, you just hit your head, jeez, or you first like jeez or jeez or jeez. Everywhere will first blur. Are you getting it? Before you come to your senses, everywhere don't blur first. That is what I'm trying to tell you. That pressure is force over area. Alright? Now, the smaller the area, the higher the pressure. Like this one, and the area is small. So the pressure will be what? High. This one, the area is a bit larger. So pressure will be what? Low. So you will not feel it as much as this other one here. Pressure is force over area. What do we say is dimension for force? MLT minus 2. Dimension for area is L squared, because L times L. So that at the end of the day, my dear students, what are you going to have now? Pressure would be equals to MLT minus 2 divided by L times L. So this cancels this, raised to the power of 1. This will become ML minus 1 T minus 2. This is solution to that question. Alright, that is solution. The next one is momentum. From here, you'll be able to get the units. What do you think the unit will be? The unit will be kilogram, meter per second. The next one is momentum. My dear student, what is momentum? Momentum is mass times velocity. That is the formula for momentum. So if momentum is mass times velocity, what is the dimension? Mass is capital letter M. Velocity is LT minus 1. So when you multiply these two things, it gives us MLT minus 1. And that is the solution to that one. All these ones are very, very simple one. Then the next one is density. What is the formula for density? Density, my dear students, indicated with this is mass over volume. Mass is capital letter M. Volume is length times length times length. We've already known that before now. So M over length times length times length will give us L to the power of 3, which should be ML to the power of minus 3. Torque is force times perpendicular distance. That is torque. Force times the perpendicular distance. Distance is radius. Radius is distance. All of them are measured with what? Length. Is that okay? All of them are measured in length. So force, MLT minus 2 times L. When you multiply these two things together, you have ML squared T minus 2. Alright? Exactly. because L times L will give us L squared, then T minus 2. Make somebody pour me water. Now pour me water. Then the next one is stress. My dear students, stress is force over area. Like I said earlier that some of you are passing through emotional stress, romantic stress, financial stress. Some persons, the greatest stress you are passing through now is financial stress. People like us, we need more money. While some of you are passing through emotional stress, then stupidity stress is when you don't have money and you're asking a girl out. She will carry you do nonsense. Gone are those days when girls used to say, I love him for who he is. Even you don't love yourself for who you are. So stress is force over area. If you remember that we did something on force over area here, pressure. So since the formulas are the same, you expect them to have the same dimension. And dimension is what? ml minus 1, t minus 2. All right? So you have ml minus 1, t minus 2. You can work it to give you this. All right? Then strain, extension over length. What is extension? Just to increase length. That is what extension is. Extension is just to what? Increase length. Is that okay? For instance, the reason why you buy extension to your wall socket is so that there will be an increase in length. Alright? Increase in length. And also increase in the ports you can actually plug your phone. So extension is still length. Length is extension. So extension over length is length over length. Length cancels length. Here will give us 1. So strain is dimensionless. Is that okay? Strain is dimensionless. So that is that. The next one is Young modulus. Young modulus is the ratio of stress over strain. Young modulus is the ratio of stress over strain, which of course is equals to, now my dear student, stress is force over area. So we have the dimension for stress earlier, ml minus 1, t minus 2. Strain, we say it does not have dimension, so is 1. So that at the end of the day, you have ml minus 1, t minus 2. All right? ml minus 1, t minus 2. All right, my dear students. So this will give us your modulus to have the same dimension as pressure. So pressure have the same dimension as stress, which have the same dimension as Young modulus. All right, so take note of that. Then the next one is power. Now power can be, we can have different formulas to get power. Whichever formulas we use and get power, we will still have the same dimension. Taught you this before. Power can be force times velocity. What is dimension for force? mlt minus 2. What is dimension for velocity? lt minus 1. Alright? So power will be equals to, now at the end of the day, what do you think you are going to have? L times L will give us L squared. T minus 2 minus 1 will give us what? Minus 3. So this is one from dimension for power. Of course, M is in kilogram, L is meter, the units now, and then this, which is the unit of power we have done before. All right. Now, power We can also have power as energy over time. Now let us take the first form of energy, potential energy over time. Potential energy is mgh, so we have mgh over time. So power would be equals to mg is what? Lt minus 2, right? Because g is acceleration due to gravity. So the dimension is Lt minus 2. G is acceleration. Any form of acceleration is whether due to gravity or due to non-gravity is what? Lt minus 2. Is that okay? Times our height L, everything over T. T is what? Seconds, which is capital letter T, because we are talking about dimension. So T is capital letter T. So power would be equals to, when you multiply these two things, you have m. L times L will give us L squared. And here will give us T minus 2. Alright? All over this T. L times L, L squared, and T minus 2, all over T. So that at the end of the day, power will be equals to m L squared T. Now, this one here, if it crosses up, it becomes minus 1. So T minus 2 minus 1. Power will be equals to ml squared T minus 3. Alright? You know why it's like that. I told you that this T to the power of 1, if it crosses up, it will give us, let me erase it, because some of you now can be very funny people. Okay, now from here, if I will start to erase them. So power m L squared T minus 2 times T raised to the power of 1. So power ml squared T minus 2, if this one becomes T raised to the power of, see they worry me, if this one cross up, it becomes minus 1. So here becomes minus 1. Alright? Because if this one here, see what I tell you now. If this one here crosses up, becomes minus 1. So that at the end of the day, P will be equals to what? M L squared T minus 2. When the bases are equal, what do? You collect 1 and add the power. Here become minus 2 minus 1. So P will be equals to M L squared T minus 2 minus 1 will give us what? Minus 3. And that is the answer to that question. Alright? That's the answer to that question. Alright. Which is still the same thing with all the ones we've done since. So this is for potential energy. It could also be for kinetic energy. It will still give you the same thing. Power. So work on this one for me. Kinetic energy over time. What's the formula for kinetic energy? Half mv squared. We are talking about dimension all over time. So this half mv, half here does not really matter. Alright? Just work on this and tell me if it will still give you the same dimension for power. Alright? Next one we are going to look at is the coefficient of friction. We have explained what coefficient of friction is earlier, and I have elucidated that. So what I'm just going to do is to go straight to the point. Now we say coefficient of friction is what? Frictional force all over the normal reaction. Alright? Now frictional force is a force, and the dimension for force is mLT minus 2. Normal reaction, as what we already outlined earlier, is also a force. The dimension is mLT minus 2. So both of them, they are forces. Now, when they cancel out, it gives you 1. And 1 is a dimensionless constant. So, coefficient of friction is dimensionless. You are going to come across something like this in the exam. They will ask you, what is the dimension of the coefficient of friction? The correct answer is that it is dimensionless. All right? Coefficient of friction is dimensionless. So the next one is energy or work. We've looked at this before. We said energy or work, they have the same unit, so the same dimension. Let us use work to work. Let us use work to work. Wow. Now, work is force times distance. All right, my dear student. Work is what? Force times distance. So what is the dimension for force? Of course, it's mLT minus 2 times what's dimension for distance is L. So the dimension for work will be m. L times L will give us L squared, then T minus 2. So that's the dimension for energy or work done. So this dimension, they say something as that for energy, because they have the same formula. Any form of energy, whether potential energy or kinetic energy. Is that understood? So please take note of that. Very, very important. Now, the next one is the coefficient of viscosity. Remember, we said coefficient of viscosity is formula for coefficient of viscosity, my dear student. Can you still remember? Is force over area times velocity gradient. What is the dimension for force? Force is mLT minus 2. What is the dimension for area? Area is length times breadth. What is the dimension for velocity gradient? Velocity gradient is, what do you say velocity gradient is? Velocity over time. So velocity gradient is LT minus 1 divided by what? Velocity over length rather, not over time. Velocity gradient is velocity over length. So all over L. When this cancel out, our velocity gradient will give us T minus 1. So if we substitute all of that into this equation, dimension will be mLT minus 2 divided by area. Of course, area is length times breadth. Length, which will give us length times length. You know why it's length times length, right? Because I told you that breadth is length and length is length. So this will give us length times length will give us L squared. So this will give us L squared. L squared still means L times L. So this L will cancel one of the L from here. Okay, that is area times velocity gradient. We still have velocity gradient, which is T minus 1. All right. So we are left with one L under here. So at the end of the day, this will be equals to M. This L will be raised to the power of 1. If it crosses up, becomes L minus 1. Then we'll have T minus 2 times. If this one crosses up, becomes T to the power of 1. So this will be equals to ML minus 1 T. Then minus 2 plus 1 will give us minus 3. So this gives us ML minus 1. I see minus 3. Minus 2 plus 1 will give us minus 1. So this is the dimension for coefficient of viscosity. What is the measurement, the unit using this? Mass is kg. L, which is length, is in meter. We have minus 1. Time, capital letter T, is in second. So this is the unit. So from the dimension, you see that you can easily get the units. Is that okay? So that is that for that particular one. The next one is moment. What did we say moment is the other time? We say moment is force times distance, also perpendicular distance. All right? The dimension for force is mLT minus 2. Dimension for distance is L. So that our moment would be equals to what, my dear students? M L T minus 2 times L. L times L will give us L squared. So this gives us ML squared T minus 2. And that is the answer to that question. So moment would be equals to ML squared T minus 2. From here, you should be able to get the units. M is mass, kilogram. L is meter. Time is in seconds. So you have something like this. And this is the answer to that question. All right? It's a very simple something. Now let's look at the next one. So we have questions here. What is the dimension of viscosity? Coefficient of viscosity, of course. Option C is the correct answer. We just did it not quite long. ML minus 1, T minus 1. See that because I've done it over and over again, it will be very, very easy for me to get the answers to this question. So for this, option C is the correct answer. All right? The next one. What is the dimension of viscosity? Still the same question, because option C, ml minus 1, T minus 1. All right? The next one. What is the dimension of surface tension coefficient? Now, my dear student, I think the correct answer is not here, but let's try. Surface tension, we didn't do surface tension, but let's do it now. There are some of the physical quantity. We cannot exhaust all. Surface tension is force that is acting on a unit length that make something to be like a stretched elastic skin. All right? So surface tension is force over length. That's surface tension. The force is what? What is the dimension for force again? MLT minus 2 all over length. L cancels L. And then we have what? MT minus 2. I know that the correct answer is not here. So the correct answer, if we change this minus 1 to 2, will be option D. All right? That's the answer to that question. Let's see the next. What is the dimension of universal gravitational constant? The universal gravitational constant is G. But we know from the law of gravity, Newton's gravitational law, it states that what, my dear student? F is equals to G M1 M2 all over what? R squared. This is over 1, cross multiply. When this one multiply by this, you have F R squared is equals to G M1 M2. All right? So divide both sides by M1 M2 so that you can get your G. Because what you are looking for, my dear student, is your G. So you have to make G subject of the formula. All right? You have to make G subject of the formula. So if you make G subject of the formula, G will be equals to what? FR squared divided by M1 M2. Now, let's look at this critically. Dimension for force, MLT minus 2. Radius, arrow, the dimension is what? L squared, because it's arrow squared, divided by M1 and M2, which are the masses, which is M times M. All right? Because M1 is mass, dimension is capital letter M. M2 is also mass, the dimension is capital letter M. All right? So G would be equals to M L, because L times L here will give us what? L cubed. L times L squared will give us L cubed. Then T minus 2. Everything divided by what? M times M. To make this easy, you can use 1M to cancel 1M here. So this is M raised to the power of 1. According to the arrangement pattern, I usually told you that M starts first, then L, and then T. This M is under here, it's raised to the power of 1. So if it crosses off, becomes what, my dear student? M minus 1, L to the power of 3, T minus 2. All right, so G is M minus 1, L to the power of 3, T minus 2, which is option C as the correct answer to this question. It's very easy, right? So please take note of it. Very, very important. All right. the next one. So we have other applications of dimensional analysis. And this one is how to check the relationship between physical quantity using dimensional analysis to check the relationship between physical quantity. So let's look at this. Now, we have a question here that says that suppose the period of oscillation T of a simple pendulum depend on the mass of the bulb, the length of the thread, and the acceleration due to gravity. Use the method of dimension to find the incorrect relation. Now, how do we do something like this? It's very easy. They say suppose the period of oscillation T. So what you are going to say is T is directly proportional to, you say it depends on the mass. So it depends on the mass, the length, so you write L, and acceleration due to gravity, G. So when they give you something like this, you first of all bring out what we have here. Suppose the period of oscillation T of a simple pendulum depends on the mass M, the length L, and the acceleration due to gravity G. Use the method of dimension. So, my dear student, T is directly proportional to M, L, and G. We want to know the relationship between T, M, L, and G. To know the relationship, most times, we usually say, let this M be raised to the power of X, which is the relationship of T with M. Let this L be raised to the power of Y, and let dg be raised to the power of z. All right? To remove the proportionality sign, we often put a constant. But most times, I don't like working with a constant. Although it's good, though, but I just prefer, okay, let's remove the proportionality sign and impute a constant, which is k. All right? So this one will be equal to what? mx ly g raised to the power of z. You know, when we are in secondary school, even primary school, they used to teach us different types of proportion, direct proportion, inverse proportion, joint proportion, and so on and so forth. So what we just did here is remove the proportionality sign and then introduce a constant, of course, which is k. So what we are going to do now is to look for the dimension of each of these. Period. Dimension for period is t. Dimension for mass is capital letter M. Dimension for L is capital letter L. Dimension for G is acceleration due to gravity, which is also acceleration. So the dimension is LT minus 2. So the only this one has a strange dimension, which is LT minus 2. All right? So what we are now going to do now is substitute their dimensions into this equation. The equation says, let's come here, T is equals to K mx ly g raised to the power of z. Substituting their dimension now, T is T, because we have our K. M is capital letter M, which is mass, raised to the power of X. L is still capital letter L, which is length, raised to the power of Y. But for G, the dimension for G is LT minus 2, which is raised to the power of Z. LT minus 2, which is raised to the power of Z. All right? Because G, we look at this one here, G is raised to the power of Z. So, and our G is LT minus 2. That was why we raised it to the power of Z. All right? LT minus 2. So in place of G, that was what we introduced. Or in place of what we have here, in place of G, we introduce this one here. Is that okay? All right. So now that we've done this, the next thing we do now is to bring out everything here, express them. So T will be equals to what? K mx ly times this LT minus 2 raised to the power of Z. This Z here will affect this L. So we have S L raised to the power of Z. Then T minus 2 times Z will give us what? Minus 2Z. What I did was just to use this Z to open through this bracket. You know, this one is like raised to the power of 1. 1 times Z will give us T minus 2Z. All right? Now, T would be equals to K mx ly Lz t minus 2z. Is that okay? Now, at the end of the day, L, you now collect like term to ensure that all of this side has only one M, one L, and one T. This place should have only one M, one L, and one T. So you are now going to say T would be Km X. The bases are equal, which is L. So what do you do to the power? Collect one and then add the power, which is Y plus Z. Then T minus 2Z. All right? Exactly. So I'm going to do here now is to rule. So that finally, this is what we have. We now have one M, one L, one T. But if you look at this part of the equation, we only have T, which is of course raised to the power of 1. Now, this part of the left-hand side of the equation must also have M, must also have L, and it must have T. So to do that, what you just do, if no M is here, just write M and raise it to the power of 0. If no L is here, just write L and raise it to the power of 0. If no T is here, just write T and raise it to the power of 1. Is that okay? Which is M to the power of 0, L to the power of 0, T to the power of 1. Is that understood? Now, the reason is because anything raised to the power of 0 is 1. L raised to the power of 0 is 1. M raised to the power of 0 is 1. 1 times 1 times T, it will still give us what? T. And we are doing this because of what will happen next, which is comparison. So this will be equals to K, M to the power of X, L to the power of Y plus Z, then T to the power of minus 2Z. Now, at this point in time, what are you doing? You compare both sides. Compare M and M. So come here and write compare both sides. All right? So if you compare both sides, M here is what? 0. Let's compare M first. So we have M to the power of 0 is equals to M here is to the power of X. So this will cancel this. Our X is equals to 0. This is equation 1. All right, because M and M cancel, you equate the power. Since both of them are the same, the power must also be equal. Then, of course, we have L to the power of 0. What is our L on this way? Y plus Z. You compare both of them so that our Y plus Z will be equals to 0, equation 2. Then, of course, T to the power of 1 is equals to T to the power of minus 2Z. When this cancel, you have 1 is equals to minus 2Z. Divide both sides by minus 2 so that our Z now will be equals to what? Minus half. So we have 3 equations. X, this is equation 3. We have X is equals to 0. Y plus Z is equals to 0. And Z is equals to minus half. So if Z is equals to minus half, Y plus Z is 0. It means in place of Z, you can put minus half. All right? So this will give us Y plus Z is equals to 0. Recall that Z is minus half. So this gives us Y minus half is equals to 0. And Y is equals to plus half. Is that okay? Y is equals to plus half. And that is the answer to that question. So Y is equals to plus half. So we've gotten all our variables. X is 0. Y is half. Z is minus half. Recall the initial this is T is equals to K mx Ly g raised to the power of Z. So you come here and say T K M first X Ly g to the power of Z. So T will be equals to K. X is 0. So you put 0 here. Y is half. g is minus half. I mean, z is minus half. Any raised to the power of 0 is 1. So t will be equals to what? K times 1, because this whole thing here will give us 1. M raised to the power of 0 will give us 1. Times L raised to the power of half times dg raised to the power of minus half. Anything minus half, you can still write it as 1 all over g raised to the power of half. Anything minus, you can put it as fraction. So if I have g raised to the power minus a, I can write it as 1 all over g raised to the power of a. Anything minus, you can put it as 1 all over that thing except the negative sign. Teaching you something now. So if you have a to the power of minus m, you can also write it as a to the power of what? 1 over a to the power of m. So that's what we did here. G raised to the power minus half, we can write it as 1 all over g raised to the power of half. All right. So finally, t will be equals to k times L raised to the power of half divided by g raised to the power of half. All right. Of course, which should be equals to t k L raised to the power of half g raised to the power of half. Of course, finally, any t raised to the power of half can also be written as square root. So this will give us t is equals to k square root of L divided by square root of g, because L raised to the power of half can be written as square root, g raised to the power of half can be written as square root. Now, because we have square root on top and down, one big square root can cover them. So we have root of L over g. And this is the final answer to this question. It's long, right? It's something you just have to memorize. Just know that x is what? 0, y is half, z is minus half. All right? Now, I have always given you this particular question. I have told you that it will come out in the exam. The same way I expect you to do it in the exam is the same way I'm going to do it here. The answer to this question is that x is 1, y is 1, and then z is also 1. So I don't expect you to solve this one. So f will be equals to k r1, this 1, v1. If you have time and you think you want to go through it, it's a very simple something. But I don't think I have that time for now. All right? So whenever you see this question in the exam, just know that the answer is 1, 1, 1. You see an option that carry a 1, 1, 1, because they may ask you to find the value of x, y, and z, or they may just tell you to find the relationship. They say find the relationship. F will be equals to what? K r, coefficient of viscosity multiplied by velocity. This will be the relationship. Why they say find x, y, and z, the values are 1, 1, and 1. All right? It's a very lengthy something, but it's not that lengthy. But I don't think I will want to go through that now. Now, we have a question here that says, if x is equals to at squared plus bt plus c, where x is distance and t is time, what will be the correct units of a, b, and c? Now, my dear student, there's something I want you to know. In dimension, so long two things are added or equated or subtracted, it means those two things have the same dimension and you can equate them. If I add at squared plus bt, it means at squared and bt have the same dimension. If I can add bt plus c, it means bt plus c have the same dimension. If I can say x is equals to at squared, it means x and at squared have the same dimension. All right, so you can equate them. So whenever you see something like this in the exam, the first thing you need to know is that s is equals to what? First, write it out that s is equals to what? At squared. This same x is also equals to bt. And this same x is also equals to c. Right? So if s is equals to at squared, s is equals to bt, s is equals to c, my dear student, what are you having at the end of the day? At the end of the day, you are going to have x will be equals to, now let's look for a t squared. Let's make a separate of the formula by dividing both sides by what? By t squared. T squared cancels t squared. A will be what? X over t squared. And a will be, what is the dimension for x? Distance is what? L. What is the dimension for t? Capital letter T, but it's squared. All right? So that at the end of the day, your A will be what? L. When this one crosses up, become T minus 2. So A will be equals to LT minus 2. L is meter. T is what? Per second square. That is the unit. All right? So correct unit for A is meter per second square. That is what you do. It's a very simple thing. Once they give you an equation like this, all you need to do is first equate what you have here to the AT square, make A separate of the formula, equate what you have here to the BT, make B separate of the formula, equate what you have here to C, and then make C separate of the formula. So let us do for the second one. S is equals to BT. So if you have X is equals to BT, my dear student, to make T separate of the formula, B separate of the formula, divide both sides by what? T. So when T cancels T here, our B will be what? X over T. X is what? Dimension for S is length. Dimension for time is capital letter T. Of course, this raised to the power of 1. So if this one crosses up, becomes LT minus 1. All right? Which your B will be LT minus 1. But they ask us for the unit. What do you think the unit will be? L is meter. Time is second. So we have meter per second as the answer. Then the last one says X is equals to C. So you come here and say X is equals to C. So if S is equals to C, it means C is equals to X. X is what? Distance. So the dimension will be what? L. Dimension for distance is L. You have to be very careful with this. S is equals to C. We make C separate of the formula because that's what we are looking for. So C is equals to X. C will now be equals to dimension for S. S is distance. Dimension for S is what? L. And C would be equals to, what is the unit for length? It's meter. So this is the answer to this question. So our A is meter per second square. Our B, meter per second. And our C is meter. This is the units. So in the exam, you see something like meter per second square, meter per second, and then meter. You should be able to go through it. All right? Now we have another question here that says, find the dimension of A over B in the following relation, where F is force, X is distance, and T is time. Find dimension of A over B. So how do we find dimension of A over B in that relation? Okay, we'll solve all these ones. Find the dimension of A over B. Let me try and solve. Now, F is A root X plus BT squared. What did I tell you? I said when you have something like this, it means that F can be equated to what? A root X. And the same F can be related to what? BT squared. Abina. So if F is A root X, it means we can make A separate of the formula because the question says, find the dimension of A over B in the following equation, where F is force. They're giving to you that F is for X is what? The distance, and T is what? Time. So coming here, make A separate of the formula by dividing both sides by root X. So root X cancel root X. Our A will be F over root X. All right? So that at the end of the day, my dear student, A will be, F is what? MLT minus 2. Then root L is what? X is what? Is L. Because X is distance and the dimension for distance is L. So you put that into that equation. All right? So that at the end, what are you going to have? Because it says you find the dimension of what? A over B. So this dimension of A. Can decide to leave it like this. And then let's go to B and C. Then we'll do our this later. For B, F is equals to BT squared, right? So we'll say also F is equals to BT squared. So make B set of the formula by dividing both sides by what? T squared. So this cancel this. Your B will be what? F over T squared. So B will be, dimension for F is what? MLT minus 2. Dimension for T squared is capital letter T squared. All right. But the question says find A over B. So A over B will be, let's come here and find A over B. A over B will be MLT minus 2 divided by root L divided by, because this is division sign now, so we'll put divided by, B is what? B is T MLT minus 2 divided by T squared. All right, so that our A over B would be equal to MLT minus 2 divided by root L times, if we put times here, T squared will come up, MLT minus 2 will come down. So here will be T squared all over MLT minus 2. This cancels this, and our A over B will be T squared all over root L. And that is the correct answer to that question. It's a very simple one, right? Exactly. So that is the correct answer to that question. When you see it in the exam, you just choose that. Let's look at the next one. The next one says, write the dimension of A and B in the relation, where P is pressure, V is volume, and T is temperature. All right, T is temperature. So write the dimension of A and B in the relation. Now, I told you that for two things to be added like this, it means their dimensions are equal. That is the meaning. Whenever two things are added, it means their dimensions are equal. So we could easily say that dimension of P is equal to that of A over V squared. Is that okay? Because once two things are added like this, their dimensions are equal. For any two things to be added, the dimension must be equal. Then multiply to make A serious to the formula, because you are looking for A. So A will be equal to what? PV squared. So our A, PV squared. What is the dimension for pressure? Say pressure is force over area, which is ML minus 1 T minus 2. That is dimension for pressure. Is that okay? Multiplied by V is volume. Volume is L raised to the power of 3. And the volume is squared, which is L raised to the power of 6. So that at the end of the day, our A will be equal to what? ML minus 1 T minus 2 times 3 times 2 will give us what? 6. All right. Collect like them. Let the L and this L come together. If they come together, my dear students, our A will be ML minus 1 plus 6 will give us 5. You know why it's minus 1 plus 6? Because these two things are equal. So you collect 1 and then add the power. Multiplication is in between there, which is minus 1 plus 6. Minus 1 plus 6 will give us 5. And then T minus 2. So your A is what? ML raised to the power of 5. T minus 2. Is that okay? Exactly. So let's look at the next one. The next one says B. So V, I told you that before two things can be added and subtracted, it means their dimension are the same. So before you can subtract B from V, it means V and B have the same dimension. So what that implies is our B is equals to V, and V is volume. So dimension for B will be L raised to the power of 3. And that is the answer to that question. So your A is ml5t minus 2. B is L raised to the power of 3. That is how to go about this particular question. All right? It's a very simple thing. In Christ alone, my hope is found. He is my God, my strength. So that is that for this one, all right? Let's see the next one. Derive the dimension of all of these, of which I have solved before. What is velocity? Say velocity is displacement over time. The dimension for displacement is L. Dimension for time is T. Of course, this is raised to the power of 1. If it crosses up, it becomes LT minus 1. All right? Then viscosity. We've done that one before now. Go back. Then for the gravitational force, we didn't do gravitational force. We did gravitational force constant. So I'm going to do gravitational force, which is Gm1, m2, all over r squared. Now listen, force is force. So dimension of any kind of force, whether gravitational or not, we end up giving you mlt minus 2. All right? All forces are forces, so they will end up giving us mlt minus 2. So we have this 2021 test. It's a very simple question. Say for a geostationary satellite of mass m and radius of orbit r orbiting a circular orbit close to the Earth's surface experiences a force giving gm1 mg all over r squared, where mg is the mass of the Earth. Use method of dimension to find the unit of g. Now, if you want to find the unit of g, it's just like giving f is gm, then capital letter mg, all over what? R squared. So you make g straight to the formula, cross multiply. Here will give us f r squared will be g, then we'll have m, then mg. So to get your g, divide both sides by mg, mmg. These two things will cancel each other. And your g will be equal to what? F r squared, all right, divided by what? Mmg. Now, this is a very simple question, all right? This is a very simple question. Now, we don't have to, they say to find the units. We don't have to go through all those processes because, of course, the unit we are giving to you in a different way entirely, where force was in Newton. So you don't have to break it down in the method of dimension. All right, my dear student. So G would be equal to, what is the unit of force? Is Newton. So you have Newton. What is the unit for radius? Radius is distance. Distance is length. So it's Newton meter square all over. These two masses, this is a mass M1, M2. This mg, the subscript g, just tell you that mass of the Earth, nothing serious. The g does not mean gravitational constant. So m times mg will still give us the unit of masses. The first mass will give us kg, times second mass will also give us kg. So that at the end of the day, you have Newton meter square per kg times kg will give us kg square. So the correct answer is Newton meter square per kg square, which is option A. This is a very simple one, all right? Option A. And that is the end of this session. We'll see you in the next one. Bye-bye. So now we are done with one of the important topic that you need to know in your physics. The next lecture, we are going to go to the next topic. We'll complete it and we'll continue from there.